Today, a quick little example of TDD in Ruby. This is a example from my real life. It happens to be the website that I use for my business, a website that I have publicly, just started getting hit with robots. It's something that's relatively normal these days. It used to be that in Rails, the CSRF token protected us from random robots submitting forms across the internet, but now the robots are even smart enough to read the forms and get through the basic form validation. I'll show you my website, I'll show you the problem, and then we'll implement the solution using TDD. Let's dive in. Okay, I'm down here. So today I'm going to use Rails as the container, but what we're actually going to do is monkey patch or open and change the class definition of the string class in Ruby, which is probably something that you shouldn't do. But as a Ruby developer, you do need to know that it is possible to do this. And you can get away with it in small apps, and you can get away with it in certain cases when you need to do it. And there are some legacy gems that monkey patch the Ruby objects, but generally it's frowned upon. But I'm going to show it to you today because we'll do something really simple, and in doing so, we'll learn some TDD. So I have a website publicly on the internet, and it looks just like this. This is it, in fact. It just has a very simple sign-up form for people who don't have an account. They just put their email address, and it happens to be optional to put the first name, last name. But in this case, the robot that is trying to hack this form appears to have figured out how to put the first name and last name in, even though it's optional. I just have to put in my email address, submit JSON, Fleetwood Bolt, and it reloads. That's all it actually does. So what happens is there is a hacker, maybe a hacker behind a robot that submits all this fake data, and he or she submits first name and last name with all this junk data in it. And you can see here in records 827 to 834, there were hundreds of records. I already cleaned them out, but this is an example. I blurred out the customer data that I have in here in the other records. But you see, actually, what you don't see here is that it looks like that the robot submits perfectly, or what look like legitimate email addresses. They're all at Yahoo or at Gmail or at Hotmail. So they look legitimate. That's the reason why it turns out to verify an email, you have to actually send an email and have them click on it to confirm the address. But in this case, I don't want to do that right away. I want to give them access to a certain amount of upfront without having them confirm the email address. So I get these robots, and the robot submits this form with first name, last name, with all this junk data in it. So now this is going to be a game of wampum. And of course, if the robot changes, then I'm going to have to build a smarter mousetrap. That's mixing my metaphors. But if I can detect that this data in first name and last name that you see here, all these uppercase, lowercase letters that are obviously not names, if I can detect that that's the robot trying to hit me, then I can automatically detect that's a junk record, throw it away, and block the IP address from doing it again, which is what I've done here. Today, I'm just going to show you how to do TDD for the one method that looks at the string that's either a first name or last name, that checks to see if it's a spam, that looks spammy. And I actually called the string looks spammy. Here we go. Okay, so the first thing I'm going to do is I'm going to create the string spec. I'm just going to create it in this spec extensions folder that I just happen to have. And because it's a Rails app, I have to require the Rails helper. But of course, you don't need to do that if you're not in Rails. And we want to start by describing our string class. Now, the convention in Rspec is to use a pound symbol for when you're unit testing, and you're testing a particular method, and you might have a cluster of tests around one method. The convention is to use a pound symbol and then followed by the method name. And in this case, my method name is going to be looks spammy question mark because it's going to return Boolean. The convention in Ruby is to end your method names with a question mark if they return just true or false, a Boolean. Then we always have to put an it block. It should return false for a non-spam looking name. And I'm a terrible typer, so go back and clean that up. Now, let's say I were to come along and use my own web form and put my own name into it. Expect JSON looks spammy to be not true, false. Right? So we have a method here called looks spammy. We don't have the method yet, but we're going to try to call a method looks spammy or more accurately send a message to this object, this string that's just the first name JSON. And we expect looks spammy to return false. Let's see what happens. Undefined method looks spammy. Okay, there we have what we call in TDD red. You might have heard red to green to refactor. Here we are at red. That's our first failing spec. And all it tells us is that we don't even have a looks spammy method at all. John, of course, looks spammy. Okay, run that. We see still no method spammy because we haven't implemented it. Now, I can, since I have the red here, technically, under the rules of TDD, in which you were supposed to watch the red first before you implement the code, you could go to the string object, which I'm going to do up here in the initializers, just because Rails happens to load the initializers when Rails boots. And I'm going to make a string extension. Now, like I said, you shouldn't normally do this or open the string class and redefine it. But in this example, I'm going to give us permission to do it because we're really talking about TDD. And it's a good learning example for how you can manipulate Ruby. It's called Ruby magic when we do this, and the real power of what Ruby and TDD allows for. So here we're just going to open the class string and add let's say false. I don't know. So if I've done that, I just put false in there, I've actually done something a little lazy that I shouldn't do. And that is that I wrote the test and I only wrote one side of the test, which is the false case, which should return false for non-spam input. But really, you should write both sides of the spec at all times, especially when you're unit testing. You need to write all the branches at first. In this case, what I've done is simple to see the error in, because I just put in false. But what if I had done something much more complicated and done something lazy like that? So let me take that out, run it again. It should tell me that there's a method now, but instead of getting false, it got nil. Let's go on and implement the true side of the branch. Now in this case, it happens that I have this robot that's hitting my database with all the spam inputs. So I actually just go in and copy and paste the exact same strings that are being passed to my application. And that's pretty convenient, and it's also a great way to test. Think about the test as what is going to happen in the real world. And if the real world changes, maybe you'll have to change the test. So here I'm going to say expect, and I'm just going to copy and paste this right from what the the robot is sending the application. To be true. Oops. To be true. This one. Third one. To be true again. And finally, oh, you know what? Got to make sure that you call, first of all, I'll show you what I did wrong here. One thing about working with Rspec is you got to get the syntax right. So here, always have to remember that when we call expect, we don't want to call expect on the string. I'll show you what happens if, yeah, that doesn't work, does it? If I accidentally forget to look spammy. Undefined method looks spammy for string. Expected false got nil. 13. Undefined method looks spammy for string. What did I do wrong there? Oh, look spammy. See, I forgot the S, plural. Always look spammy. So I left another mistake in there. Oh, wait. Yeah. So expected looks spammy to be true, but it got nil. And here is expected false, and it got nil. Now, I left another mistake here, which is that I accidentally did not put the look spammy method onto the string in this line 15. I'm going to fix that mistake in just 1 second. Actually, let's fix it now. Let's do it this way. This is the fix for the same line of code. Remember to always call look spammy on the thing you're testing, the method that you're testing on the thing that you're testing. If you forget to do that, like I've done here, bad things will happen, which we'll see in just a second. Okay, so now we have the basic false cases and true cases with one error there on line 15. And let's see what happens when we run them. Okay, a bunch of failures. Well, just 2 failures because I have just 2 it blocks. Expected false to be nil, expected this thing to be true. Okay, let's try to implement look spammy. See if we can do it. But the first thing I actually want to do is I want to figure out how many times, because I have these strings, right? Let's say, I'm going to just type the strings out here in a text file. I'll put them up here for you. Fleetwood Bolt, that's my name. That's a string, JSON, and then we have these weird case things, uppercase, lowercase, upper. Not very good here. I'll go copy them from back here. These weird case things, right? Just to show you them again. So here we want to figure out which one's spam and which one's not spam. Now, the first thing that comes to mind is we should check to see how many times in the string the case switches from uppercase to lowercase, from lowercase to uppercase. Each time that it switches will count as a switch. If it switches more than, I don't know, 2, 3, 4 times, then it's spam. So let's write a very simple method that just goes through the characters and checks how many times they switch from uppercase to lowercase to uppercase, or back and forth like that. I'm gonna need a switches, which I'm actually gonna set to -1. Little bit cheating, but I'm doing that because the very first character is always going to increment switches to 0, which is actually what I want, because that's always going to be switch. There's 0 switches at the first character. The last case will be a variable that will hold a symbol. It will either be upper or lower. No, actually it's going to be nil right now, but normally it's going to be either upper or lower. In the case of the first character, it's going to be nil. And now we simply want to basically do an each over the characters. This is pretty crude. So there could be a much better implementation, and I invite you to use the same specs to write a better implementation of this, which is the fun part of TDD, because after you have the passing specs, you can then go refactor. We're going to do self-chars each, which just says loop over each of the characters. And then in this block here, we're going to have the arity of the block be char, which means for each time that we call this block, the char is going to be the next character in the string. We're going to have an if statement here, an if-else if statement here, and basically just take a look at it and then tell me what you think. The last case does not equal upper, and we're going to use a regex. Now, regex upper colon, this fancy thing here. That's just a regex that says, does this character, single character, match A through Z, but all the capital A through Z's, right? So A, B, C, D, E, F, G through Z. So is this character uppercase? If the last character was not uppercase, and this character is uppercase, then we're going to add 1 to switches. And, whoops, sorry. We're going to set the last case to upper for the next time we go through the loop. Then we'll do an else if and the opposite. Last case does not equal lower, and this funky, very funky looking regex. Sorry, close the brace there. Those 2 braces. Match CHR. Then we also have switched case, so we also want to add 1 or increment switches by 1. Equals 1. And the next time we're going to set the last case to lower. Now, okay, so at the end of all of this, we have all we've really done is we've counted the number of times that it's switched from uppercase to lowercase. So then we want to say, I don't know, does it look spammy? Maybe if it switches from uppercase to lowercase like more than like 2 times, then it's spammy. Okay, so spammy, so return, we don't actually need the return in Ruby, but let's do it for good measure anyway. Spammy, no, switches, sorry. Return switches is greater than 2. So switches greater than 2, then we'll return true. If it's not, we'll return false. There's a little turn array that we don't need, but for demonstration, it shows exactly what's happening. If we've switched more than 2 times, then we think that the string looks spammy. If we haven't switched more than 2 times, then we think that it does not look spammy. All right, let's see what our tests think. Okay, so we said here, if switches is greater than 2, then it looks spammy. If it's switches from uppercase to lowercase fewer than 2 times, like 0 or 1 time, or 2 times, because actually it says greater than, so that would mean you'd have to switch 3 times or more, then it looks spammy. Let's see what happens when we run this. Oh, string looks spammy should return false for Fleetwood Bolt, which is my name. So that's a bummer. Why does it think that my name switches from uppercase to lowercase or lowercase to uppercase 3 times? Well, it's actually because it switches from F to L, uppercase to lowercase, and then it doesn't count the hyphen based on the fact that the hyphen, if you look at our implementation again, the hyphen will not match for either upper or lower. So both of these will be false, which means it'll just move through to the next character. And then when it gets to the B, it'll say that it switched from lowercase to uppercase because it was last character D was lowercase. And then when it switches from B to O, it'll say that's the third switch. So that's actually 3 switches in my name. So that doesn't work. So let's say if it switches more than 3 times. Let's try that. If it switches more than 3 times, let's see what happens. Oh, look, Fleetwood Bolt, my name passed its spec, but now I got a different failure because of my implementation. So a different spec, actually the negative case, which is spec, failed. This one happens to be line 17 right here. So that's unfortunate. What are we going to do about that? Let's see. So we just have to make a smarter look spammy, right? If it switches more than 3 times, in this case, NJ0YZPVC, that doesn't switch more than 3 times. That just switches like maybe 1 time from Y to Z, lowercase to uppercase. So, but it has ZPVC, that's like 4 uppercase letters. Nobody really has 4 uppercase letters, do they, in their name? So maybe we should detect the number of times that it switches, and then also detect the total number of uppercase characters that are in the string. Okay, so my implementation does not work. That's a bummer, but let's keep going. As a reminder, here's our specs, and here's our failing spec that we call look spammy on this weird string that has lowercase characters in the beginning and then uppercase characters in the end. They don't change characters very often. It should look spammy, but it doesn't in my current implementation. My current implementation is here. If switches is greater than 3. So what do I want next? I want a method that's going to count the number of characters. So, for example, for Fleetwood Bolt, it's going to count F and B as here it's going to count F and B as uppercase. But for this weird string here, it's going to count ZPVC as 4 uppercase characters, and it's not going to allow that. So it's going to be able to tell Fleetwood Bolt has 2 uppercase characters, and let's see if that works. I don't know if that's going to work perfectly. Let's give it a try. I'm going to call this method count upper. We're still on the string class. Let's just keep going. Count upper is going to return this. How many? Let's see. It should return 0 for, let's say, 0 for an empty string. And let's say, I'm going to write these in just 1 second, but I like to just put out empty it statements just to give myself a sense of where I am. It should 0 for a string with no uppercase. With all, how about let's call this all uppercase. So let's do expect empty string, and let's do count upper to EQ 0. We're expecting the return of count upper called on the empty string method to equal 0. Or more precisely, we're expecting the return of the message count upper that is sent to the empty string object. This is actually going to be the same thing, so we can copy and paste. And let's run it and see what we get. Okay, so we still have look spammy problem up here. This doesn't make any sense. We're just leaving it as a problem. And then I have this undefined method count upper because I don't have the method count upper. So I just dreamt up this method. I haven't even used it. Let's go use it from look spammy. So here I want to do, basically what I want to do is I want to do switches is greater than 3, or the count upper is greater than 2. Does that work? Let's see if that works. So if we have more than 2 uppercase characters, or we've switched case more than 3 times. I don't know, it sounds reasonable. Does that work? So undefined method count upper. Undefined method count upper for string. Okay, let's implement it. I don't know, it just has to be a number, so 1. But that's a lie, because not all strings have 1 number. Oh yes, this is, right, count, expect empty string to equal 0. So, I don't know, if empty string, then return 0. Oh yeah, so this is a bad implementation. I mean, it's a implementation that makes the specs pass, but I didn't write the negative case. You see, I only expected 0. This doesn't make any sense. By the way, I did the same expectation twice. This should be expect to return a string for this is completely wrong. Should return 0 for a string with only lowercase characters. And that's going to be like that. Yes, so it's returning 0 all the time because I told it to return 0, but that's cheating. You always have to test the negative case. This is a great example of why you have to test the negative case. Do as I say, not as I do. So it should return 1 for a string with 1 uppercase. 2. Expect. Lots of little lowercase characters, and we'll give 1 uppercase character in the middle there, an X. Count upper. To be 1. And let's, just for good measure, we'll copy and paste that. Should return 3 for a string with 3 uppercase characters, and then we're going to do, I don't know, Yahoo, ABC, and then XYZ. Should be 3. So you say 3 uppercase characters. Okay, let's see if that works. Oh no, we still got 0. Because I implemented the negative case, and I was just lazier, and I always return 0. So if it's empty strings, then yeah. So let's say, let's do self.length. Does that work? Oh no. Self.length. Oh look, ABC. No. Self.length gives me the total number of characters in the string. I only want the uppercase characters in the string. An integer that represents the number of uppercase characters. So I'm just going to use a little, just get a little fancy on you here. I'm just going to use a regex. Don't worry, I'll explain it. And here I'm going to ask for not, and the caret here is going to do the not. So just note that we're going to do caret, capital A through capital Z. And then we're going to close that. And that's the regex, comma. Replace that with an empty string. So any characters that are not uppercase, replace that with empty string. So that means that anything that's not A through Z, we're going to replace that, we're going to take away. So we're going to only be left with the uppercase characters, and then we're going to count them. It happens that if this, because of the way regex works, we might not be able to call length here. Let's give it a try. Length or 0. Let's give it a try. Oh, that passes. Amazing. Amazing. Okay, so let's give it a try. Passing. Passing specs. Yay, party. Let's party and refactor and make sure that we have both sides of our use cases covered. This was not me. This was someone else. I think maybe my doppelganger from an alternate universe, because I do not do this. I would not do this. I don't recommend doing this, but maybe you do it, and I'm not judging. So you come along a web form like this, and the first thing you do is you put in, your email address, fleetwood@nowhere.com, and then you put your name in all capitals. Like, who does that? Does anyone do that? I don't know. Maybe you do that. Maybe you type all capitals into web forms. Maybe you type all lowercase. So this does happen, and there are legitimate people who do all capitals and all lowercase. So what happens if they come in? Let's give it a try. So I'm going to come in from the alternate universe, and I'm going to be Fleetwood Bolt, who types his name all capitals, which I would never do, but the alternate me might. And he's not spammy. I want him to use my web form and my web application in this universe. I'd really like for him to do that. I mean, to be welcomed in this universe. So he's not spammy. Let's see what happens. Oh no. I think that's because in string extension, I counted the number of uppercase characters, and if there were more than 2, I said that it was spammy. That doesn't work. So there's an edge case that doesn't work, and let's see what else. Let's say if I type lowercase. That works. So lowercase Fleetwood Bolt is fine. So we're okay there. So let's make this a wee more complicated. What do we need to do? Well, I think based on what I know now, that we have a robot that's sending in this weird traffic. Remember, I'll show you the weird traffic. See the weird traffic here. In first name, last name. And we have legitimate users who are sending in sometimes forms that are correctly cased with their first letter uppercase. Sometimes they have names that have more than one uppercase letter. Sometimes they send in a form that's all uppercase or all lowercase. So we want to account for all those cases, and we can do that with test-driven development. Let's keep going. Okay, so just as a reminder, this is the current state of our implementation and our specs. These are our specs. Look spammy, count upper, and our implementation is quite a bit more compact, just like that. One thing that occurs to me before we continue is that this implementation has a little bit of a separation of concerns problem. Look spammy counts the string and then also does this thing with calling count upper. It probably would be a slightly cleaner implementation if I took the parts of looks spammy where it counted the switches from uppercase to lowercase, and I abstract that out into a separate method. I don't know. Let's say I wanted to call that count switches. Something like that. So let's go back to our specs. In this case, we already have these great specs for look spammy. So we're just going to add here because we're changing the implementation details without actually changing the expected result for look spammy. Okay, and it should return 0 for an empty string. Do expect empty string count switches to EQ 0. Should actually always prefer EQ over B, and that's because B is for object equality and EQ will do evaluation equality. So expect empty string count switches to EQ 0. Let's copy and paste that. It should be, I don't know, return 0 for a string that's all lowercase. And then this will be A, B, C, D, E, F, G, H. Okay. And then let's say it should return 0 for my name. for Fleetwood Bolt, all uppercase, my name, that is. Right? And let's give it a positive case. So let's say it should return 3 for, let's say, a string that switches 3 times. And this is going to be, let's say that's going to be lowercase a, uppercase b, lowercase c, uppercase d. So from A to B is 1 switch, from B to C is 2 switches, from C to D is the 3rd switch. And then, of course, it's going to have to be expect to equal 3, right? Let's run this and see what happens. Okay, so look spammy, Fleetwood bolts, expected false got true. That's the problem we're trying to solve. So we're going deeper into the problem to add more functionality here. Count switches got expected 0, got nil. That's because I implemented my count switches empty like that. With strict TDD, you should write your spec first, watch it fail, particularly you watch for the undefined method count switches. That means you can go then implement the method. Of course, if I implement the method just empty, it will return nil. Expected 0 got nil, expected 0 got nil, expected 0 got nil. So this is already implemented for us. I did it up here. It's going to copy and paste and return switches, as you can see. Now, since I just abstracted out all of that code from look spammy, switches is now going to be count switches. I'm going to call it down here. And let's see what that does. Okay, so expected Fleetwood Bolt, all caps, to be false, but it was true. So that's not fixed because we haven't done any fix there. And then expected empty string count switches to equal 0 got -1. That's because I initialized switches to -1 up here. Why does it do that? Count upper, expected empty string count switches to equal 0. So if I give it empty string and it never switches, then it returns -1. We can do switches, comma 0 max, which will just either return 0 or the integer switches, whichever one is the greatest one. So if switches is greater than 0, it will return switches. If switches is -1, it will return 0. That's what happens when you call max on an array like that. So that passed, that got rid of our old, remember our old spec there, return switches. Just show you that again. Switches, let's just run this one spec. Remember, you can run one spec in Rspec by giving it the line number. See here, 24. So I'm just going to run 24 so we can focus in on this -1 problem. Expected 0 got -1 because I initialized switches to -1 up here because I was lazy. So I have to account for that now by doing 0, comma switches in an array and then choosing the max. Either the maximum, whichever is the greater of 0 or switches, is the one that gets returned. So if switches is -1, then 0 gets returned, which makes our spec pass there. Okay, we're so close. Now let's run all the specs again. Fleetwood Bolt. If someone comes and types all uppercase characters, then it says that it looks spammy, but it shouldn't. So how do I want to deal with that? What I actually want to do is I actually want to just detect if someone has typed all uppercase characters. Now this won't be very good if the robot figures out that that's what I've done, but in my case, since the robot is sending these mixed case characters, I can get away with it. So let's keep going with TDD and continue to solve this problem using TDD. Okay, so let's say that I wanted a method on my string that would tell me if a string if the string was all uppercase or not. And let's call this method, we're going to keep extending the string class, and we're going to call it all uppercase question mark. It's going to return either true or false, and in Ruby, we use the question mark at the end of the method names by convention if they return Boolean, true or false. It should return true if the string is all uppercase. Do expect. So Fleetwood Bolt, all uppercase to EQ true. Expect Johnson, all uppercase to EQ true. Expect A, B, C, D, E, F, G. Let's give it some spaces, maybe. Some periods. All uppercase to EQ true. And let's write the negative cases. It should return false if the string has any lowercase characters. Do expect to EQ true. Expect, and let's say I have a bunch of uppercase and one lowercase character there. To EQ. Now the great thing about having done this all TDD is that we're actually so close to finishing, and that's because we really just have two little edits to do. Undefined method, all uppercase on the string extension. Now that we have that, we can define it. So let's run that again, even just with the empty. So expected true got nil, expected true got nil. So how are we going to tell if a string is all uppercase? Well, let's see. We could G-sub out everything that's not uppercase, right? G-sub out everything that's not uppercase and compare it to self. So if we take everything that's not uppercase away and it's the same string, then we know that it's all uppercase. Does that work? Well, unfortunately, I've got this funny hyphen in my name, so that often causes problems because, of course, here if I G-sub away everything that's not uppercase equals self, expected true that got false. That doesn't work. Let's see. I don't know why that doesn't work. Oh, yes. Let's try this one at a time. See why this doesn't work. 60. Now, what's neat about running these specs is that we can drop right into the debugger right here. So 60 is the one. Let's look at the spec on line 60. That's this guy. I think we're in this one. And in the debugger, if we do self, I get all caps Fleetwood Bolt. And then if I G-sub everything that's not all caps A through Z with empty string, then I just G-sub out that hyphen. And I get my name all caps. And does that equal self? No, it does not equal self. So that's why it fails, because it's expecting true, but it's getting false. So this doesn't particularly work so well. Let's try the other one. The other one's on line 66. The negative case on line 66. It says expected Fleetwood Bolt, all uppercase. Oh yes, this is wrong. See, the tests are wrong. You should have caught me. To equal false. To equal false. Okay, let's run that again. Always make sure that your tests are written correctly. Okay, and that passes. So let's run the whole suite. Okay, so again, we have the problems with the all uppercase. It's expecting Fleetwood Bolt, all uppercase to equal true, but it's not. And let's gonna fix this using just a slightly different way of doing this. We're just gonna call self.upper. And the difference between self The difference between self.upper, here I'll leave this code commented out so you can look at it. The difference between what I'm going to do next is this. Self.upper equals self. And the difference between, here I've g-subbed away all of the characters that are not uppercase characters. I've taken them out of the string. Self.upper, so in my name, Fleetwood Bolt, Fleetwood hyphen Bolt becomes Fleetwood Bolt with no hyphen. That's what my implementation with the g-sub does. In this implementation, the second implementation, lowercase Fleetwood Bolt simply becomes uppercase Fleetwood Bolt, and it leaves the hyphen right in place. And that's so that lowercase Fleetwood Bolt, it will leave it. If it's uppercase, if it's already uppercase Fleetwood Bolt, then we'll keep it the same, and it will return true. It will be the same because I've changed it from all uppercase to all uppercase, and I'm just comparing it to its original value. Take this away, and let's see what our specs think. Undefined method upper for Fleetwood bolts. I think that's because I'm actually looking for a method called upcase, not upper. Expect Fleetwood bolt looks spammy to be false. Now, this is because I didn't actually use my all uppercase at all. So what I want to do is I want to say if it switches. So first of all, if it switches at all, then it can't be all uppercase. We know that because it would have to switch 3 times. And that means at least one time it's going to be lowercase. So if it switches, or there's more than 2 uppercase characters, and it's not all uppercase. Does that make sense? If it's not all uppercase, and there's more than 2 uppercase characters, then it's spam. Or we ignore that whole side of the condition. If it switches between uppercase and lowercase 3 times, more than 3 times, then it's spam. Does that make sense? Let me say that again. If it's kind of easy to explain the Boolean if you just break it apart. If it switches more than 3 times, then it's definitely spam. If that's not true, then we go to this other condition on the right side of the OR symbol here. The OR symbol is here. And the other condition says that both of these have to be true. There have to be more than 2 uppercase characters, and we have to not have all of the characters be uppercase. Because if somebody types all uppercase characters, we want to allow that. What do our tests think? 12 examples, 12 passing specs. Looks implemented to me. This is code complete for today. Now, of course, the robot's going to get smarter. It's going to figure out what I've done, and it's going to send me more spam. That's why this isn't really going to work in the long run. But in my case, it's a pretty good approximate solution for what I need. And as you can see, the implementation is nice and tight. That count switches method probably could be a little bit less procedural, could be just a little tighter in there. But the methods are named pretty well. Like I said before, I have opened the string class and added these methods onto it, which is not recommended because let's say the Ruby implementers in the next version of Ruby want to implement a look spammy or a count switches or a count upper or all uppercase, then those native methods would collide with the ones that you've monkey patched onto the string class. But occasionally you will see people do this, and it's important that you know how to do this. And of course, these same rules of TDD could apply to an extension to the string class. But I don't mean an extension to the string class, I mean an extended object, an object in which you extend the string class, or something like that. Some other kind of object that's, say, a user input object, where a user input might extend the string class and add these methods to it. That would be one good implementation that you wouldn't have to monkey patch the string class, just as a suggestion. I hope you've enjoyed today's lesson in TDD. We've just been dabbling around. Take all of it with a grain of salt. This is the traditional way to do TDD, test first development. You first write your tests. You write a nice, good, solid suite of tests. In our case, it all has to do with string inputs. So my specs can be very much strings, as you see. It just looks at lots of different strings, and it asserts different things. Someone might come along, be able to break this. Put in a name that I haven't thought of that gets trapped up in the looks spammy filter and gets trapped, but shouldn't get trapped. In that case, I'll have to come back and modify. For that case, I would add the specs here and then re-implement to make my code even smarter. Thanks so much for joining. If you like this kind of stuff, please check me out at JFB Codes on Instagram or Facebook. That's JFB Codes. And until next time.